Hello students, welcome to RLD Academy. In this video, we are going to solve this problem. We have one expression, one equation x4 minus 4x plus 1 equals to 0. We need to find out the number of distinct real solutions. So these kind of problems are coming regularly in JEE main papers. This problem came in JEE main 2022. And we are going to solve this problem. And I'll provide two methods for this problem. First one we'll solve with calculus concept, and second one we'll be solving without any calculus. Simply one graphs. From the graphs only we can solve this problem as well. How many numbers, distinct real solutions are there that could be solved. So this will be more interesting. Okay, so first let us consider the first approach with calculus. Now we have this equation x to the power 4 minus 4x plus 1 equals to 0. We will consider one function f of x equals to x to the power 4 minus 4x plus 1. Right? So what we will do? So we will try to understand itself. Now as its power is x to the power 4 and power is even, and this is one dominating power, right? So at x equals to plus infinity, as this sign is positive, its value will be infinite. Again, when x is minus infinity, then also its value will be plus infinity. That means on the both sides, positive side and negative side, this signal is growing and growing towards infinity. So what we can have? We can have some local minima for this function, right? So we can find the local minimas. It can have one minima, it can have two minimas, okay? But can it have more than two minimas? If the order is 4, you can think, okay? Now, then what we'll do at the minima, okay? What is the function value? That minimum value, whether it is less than 0 or not, that we need to check. If this minimum value is less than 0, then only we will have some real roots for the equation fx equals to 0, because we can expect that as it is growing both sides infinity and its minimum value is negative, so obviously it will cross the 0 axis line. Okay, so this is 0 axis line, x axis it will cross. Thus we will get some solutions, real solutions. Okay. So this is the idea. Now if it is not true, if f minimum is more than 0, then obviously it will not cross the this 0 axis. Okay, like this. If this is my function, if minimum value is more than 0, so it is above this axis, so obviously it will not cross this line and you won't get any real solutions. So solutions will be complex and complex conjugate, right? So there is no solutions. But if I find this kind of natures, so its minimum value is something negative, obviously it will cross here and here. Thus we will get two distinct real solutions. Here I have shown that we are having only one minima. Okay. Now if I have again one minima, but that time this value is 0, so you can see that we can have only one distinct real solutions. We will get two solutions, but both the solutions are equal. Okay, so here you will find that f minimum is exactly equals to 0. So if at the minima its value is exactly 0, it will just touch this real axis. So we can have two equal solutions, right? So here it is two distinct real solutions. That is important in nature. So f minimum is less than 0, we will find two distinct real solutions, but here we will get only one distinct real solution. Now if the shape is like this, we can have more than one minima, it is two minima, but both at these two minimas, this local minima, here function value is positive, here also function value is positive, so obviously this function will not cross the 0 axis, okay, x axis. So there could not be any solution, right? But if it is like this, at these two minimas, the function value is negative, so obviously it has crossed the real axis and we are getting 4 distinct real solutions, right? Similarly, it can have like this. So here only just this function value is 0. So 2 unequal solutions here and another 2 equal solutions we can get. So 3 distinct solutions like that we can get. So in that way we may have several kind of solutions, distinct solutions. Okay. So what we want to imply here that first we need to find out how many minimas are there. Okay. And in every local minimas we need to find out those function values. And based on that thing we can decide how many distinct solutions will be there. Okay. This is the concept. So what we will do here, first we will take derivative df dx. Okay, so this derivative x4, so derivative of this one is 4 into x cube and its derivative will be only 4. So I will get 4x cube minus 4 into 1 and this derivative is 0. Now I can take 4 common, so x cube minus 1 and that we can have factors. It's x minus 1 and this is x squared plus x plus 1. Okay. Now to get the maxima or minima, what we will do? We will put this derivative df dx equals to 0. We will get the critical points. Okay. At those points we can have maxima or minima. In this case, what we will get? We will get only one solution, x minus 1 equal to 0, because this part x squared plus x plus 1, it is always more than equal to 0. So we won't get any real solution for this term, right? So only we will get x equals to 1 as a solution. So there we can have only minima because function is growing on both sides. So at this point it can have the minima only. There is no need to test for maxima or minima. We are sure that at this point the function will have one minima. Okay. So at this minima, we need to find out function value. So what the minimum value? So I'll replace x equal to 1 in the original function. So this x is replaced by 1 here. So 1 to the 4 minus 4 into 1 plus 1. This will give you 1 minus 4 plus 1. So the 1 plus 1 is 2 minus 4 equal to minus 2. So this is negative. Okay. As it is negative, obviously we can see that the function will cross the 0 axis and it will have 2 distinct real solutions like this. So this is the exact plot that I have shown here. So this is the minima here at this point, x equals to 1, we are having the minima and these are the 2 cross points. So here we will have 2 solutions and these 2 are distinct and real. Thus we are having 2 distinct real solutions. I hope this is clear to you. Now we will go for the second method without calculation. Now before that, may I ask you for one like. If you are enjoying this video, please press the like button and please encourage me. Now let us consider the second method. Now what I will do here, this x to the power 4 minus 4x plus 1 equals to 0. I rewrite this thing as x to the power 4 plus 1 equals to 4x. This is left hand side, this is right hand side. Then we will consider this one as one function f1x and this is another function f2x. And f1x equals to f2x. If it is true, means when f1x and f2x will cross, then only we will get the solutions. So how many times f1x and f2x will cross each other, intersect each other, that is the number of solutions. Okay, that we will try to find out. So here f1x is x to the power 4 plus 1 and f2x is 4x. So this is one linear equation and this is x to the power 4 plus 1. This is also very simple, we can draw it. Okay. Now I will try to draw this first equation. Before that, just I will draw x to the power 4 first. The function x to the power 4, that is very simple. it is just growing on both sides like x square. Now it is more. So you can see it is growing very fast. So after this one it's almost 0, right? So this is the plot for x to the power 4. It's an even function. Now if I add 1, so it will have only one level shift. Each value is added with 1. So when it is 0, it will now become 1. And when it is become 2, that will come to 3, like that. So x to the power 4 plus 1 will look like this. So this one will be around 1 at 1 level. Then it is growing this side and this side. So this is clear, very clear. Now I'll try to draw these things, this linear plot 4x, y equal to 4x. So you can see that this function y equal to 4x, it will pass through the origin and with the slope 4. Now question is whether this linear function will cross this curve or not. Okay, so how to make sure that whether it will cross this or not. So can I find one point, okay, like this. If I consider only very simple 1, put x equal to 1 here. So this function will give you at 1, what is the value? This value will be 1 plus 1, this point, right? So 1 plus 1 equals to 2. Very simple. This function is giving you at 1 it is 2. Clear? Now this function at 1, f2 of 1 will be 4 into 1 equals to 4. So its value is larger than f1. Meaning is that this f2x will cross this one. It will be more than these things, because initially at 0 it is here only. Okay, at x equal to 0, f2 0 is 0. Now it will grow, okay, with the slope 4, and that time its value is more than 2, it's coming at 4 here. So obviously it is inside this one, right? So I can expect that this 4x, this plot will cross this curve, and obviously it is going to cut this curve by 2 points, 2 distinct points. So from the figures it is very easy to say that we will have only 2 intersection points and both are different. So it is not a tangent. If it is a tangent, then it could be only one solutions, equal solutions, okay? But here we are having 2 distinct solutions, so it is very clear from this figure. So from these methods, you can see without taking any derivative or all those things, we can conclude that these equations will have 2 real distinct solutions, right, here and here. I hope you have got this point. So these kind of problems are coming regularly in JEE papers, okay? And I'll suggest you to go through this video. There I have discussed 2 more problems, how to find the real numbers, real solutions of the 4 equations. And this is very interesting. I hope you will enjoy this video too. So thanks for watching. We will be discussing more problems in the next videos.